Let's face it, spec sheets can be intimidating. Whether you're new to hi-fi or have been listening for decades, reading amplifier specifications often feels like trying to decipher a foreign language that's designed to confuse rather than inform. But in reality, specs can help you make smarter buying decisions only if you know what they actually mean. The trick is learning which numbers matter, which ones can be misleading, and how to interpret the whole picture without getting caught up in marketing hype. In this guide, I will demystify the most common and the most misused specs you'll find on amplifier datasheets and show you how to use them as practical tools in your audio journey. First one, power output. It's not just about the watts. Let's start with the most shouted about stat. Power output usually goes something like this: 100 watts per channel into 8 ohms. Sounds impressive, right? But here's what matters more than the number itself. Is the rating given at full bandwidth? Look for 20 hertz to 20 kilohertz rather than just at 1 kilohertz. And at what distortion level? 100 watts at 1% total harmonic distortion is very different from 100 watts at 0.01 total harmonic distortion. Is it continuous power or is it a short-term peak? Continuous is the meaningful one. But what if the rating is at 1% total harmonic distortion? Some very high quality tube amps are rated at 1% THD and still sound phenomenal. That's because not all distortion is created equal. Tube amplifiers often produce even order harmonic distortion, which blends more naturally with musical overtones and is perceived as warm or euphonic, unlike the harsher odd ordered distortion found in overdriven solid-state circuits. Now, some may rightfully ask, if the goal is zero distortion, why does the type odd versus even harmonics even matter? The answer lies in how distortion behaves at real listening levels. So yes, less distortion is generally better, but not all distortion sounds equally bad, and how and when it appears is just as important as the number itself. Don't judge tube amps by the same distortion standards as solid-state gear. Context matters, and so does the character of the distortion, not just the quantity. Number 2, total harmonic distortion, THD, which we just mentioned. THD measures how much distortion the amp adds to the original signal, typically shown as a percentage. Lower is generally better, but only to a point. Below 0.1% is excellent. Tube amps often have a higher THD, as I mentioned just a minute ago. It tends to be even order and is perceived by our ear and interpreted as more musical. Beyond a certain point, ultra-low distortion becomes inaudible, and chasing numbers can lead to sterile, lifeless sound. Don't obsess over the decimals unless you're running measurement gear. Number 3, signal-to-noise ratio, SNR. SNR tells you how much louder the music signal is compared to the amp's own noise floor, and higher is better. 90 plus dB is good, 100 plus dB is excellent. Now look for A-weighted SNR, which means the measurement was adjusted to reflect how our ears actually perceive noise. Human hearing is less sensitive to deep infrasonic bass and high treble. So A weighting filters out those extremes to give a more realistic reading. If 2 amps list 100 dB SNR and only one says A weighted, that's probably the more useful number. If no weighting is mentioned, assume it's not A weighted and it may not reflect actual audible performance. Number 4 is input sensitivity. This is about how loud is loud enough. This spec tells you how much voltage is needed to drive the amp to full power. It matters for system matching and gain matching, especially if you're pairing an amp with a low output source like a preamp or a source with modest gain. Typical values are 1 volt to 2 volts. If your amp seems underpowered at full volume, check the input sensitivity before blaming your speakers. Number 5, damping factor. This is about control in the low end. Damping factor is the amp's ability to control speaker movement, especially in the bass. It's the ratio of the speaker's impedance to the amplifier's output impedance. Damping factors from 20 to 100 is typical for solid-state amps. Tube amps often have lower damping factors, sometimes as low as 5 or below. Again, sometimes this could result in looser or more romantic bass. Note carefully here, not all damping factors mean flabby bass. Take the Audio Research VSI 60 as an example. It has a damping factor of around 4. It still manages to control speakers like Wilson Audios that are notorious for demanding loads with ease and authority. Why is that? Because damping factor isn't everything. Factors like transformer design, amounts of negative feedback, power supply quality, speaker synergy all play major roles in actual bass performance. So what should you take away from this? Higher damping factor is a helpful guideline, especially for solid state. Low damping factor in a good tube amp does not necessarily mean bad bass. There are other design factors at play. As always, it's about system synergy, not chasing spec numbers in isolation. Okay, number 6 is slew rate. Speed matters more than you think. Slew rate measures how fast an amplifier can respond to changes in signal voltage, expressed in volts per microsecond. This is crucial for transient response, how cleanly an amp reproduces fast musical attacks like drum snare hits or sharp piano notes. 10 to 30 is typical, 50 plus is considered very fast and may improve clarity and impact. But beware, a high slew rate alone doesn't carry musicality. It must be part of a well-balanced design. Like total harmonic distortion, the context matters more than the spec itself. Number 7, frequency response, the range of the music. This tells you what frequencies the amp can reproduce typically something like 20 Hz to 20 kHz plus or minus 0.5 dB. That plus or minus dB number is the tolerance, and that's key. A wide range with a big deviation like plus or minus 3 dB may not sound neutral. Some boutique or tube amps may intentionally roll off highs or lows for a musical coloration. If a manufacturer claims a wider than normal response, say 10 Hz to 80 kHz, check how flat it says it's within that range. Flatter is usually better for neutrality. Current capacity and load handling. 4 ohms isn't optional unless you know why. This spec shows how well an amp handles demanding speakers, particularly low impedance loads like 4 ohms, which draws more current. In modern solid state amps, power should almost double from 8 to 4 ohms if the amp has a strong power supply. An example is 100 watts at 8 ohms, 180 watts at 4 ohms is good power. Now, if the power drops into 4 ohms when compared to 8 ohms, I'd stay away. If a solid state amp doesn't list a 4 ohm spec, or worse, warns against using 4 ohm speakers, that's a serious limitation. Another way to put it, a solid state amp that cannot handle 4 ohm loads or isn't rated at all may overheat, distort, or trigger protection circuits with more demanding speakers. Now, tube amps handle load differently due to output transformers with impedance taps. Some of them have 4, 8, and 16 ohms. Power may stay the same across loads, and that's perfectly fine. Look for a note that says 20 watts into 4 ohm or 8 ohm using the respective power tap. Match your speakers to the correct power tap. to ensure proper damping and tonal balance. For tube designs, equal power into 4 and 8 ohms is expected. It's not a flaw. Number 9, what if the specs aren't available? Don't panic. Not every manufacturer publishes full specs, and that's not necessarily a red flag. Seek out reviews and impressions. Ask the right questions. Don't hesitate to contact the manufacturer or dealer and ask, is it stable into 4 ohm, 2 ohm loads? What's the signal to noise ratio? What's the input sensitivity? For tube amps, are there impedance taps? And how was the power measured? Match to your system, not to the myth. Specs matter more when you're pushing limits. Example, inefficient speakers, very large rooms. For simpler systems, trust the sound more than the spec sheet. Trust your ears and your gut. Some amazing amps are sparsely documented but highly musical. Some spec monsters sound sterile. Don't let a missing chart stop you from discovering something special. So, specs are a good start, like clues, but not gospel. Knowing how to read an amplifier spec sheet is not about becoming an engineer. It's about becoming a smarter consumer, smarter listener, and a more empowered buyer. Use the numbers as clues, not as commandments. The best gear will show its true color not just on paper, but in your room with your music through your ears. Want more help choosing the right amp? Check out my video playlist. It's geared for those of us who are not technical without drowning you in engineering terms. Let's build a system that speaks to our ears, not to spec sheets.